In this example, we are going to look at a uniform motion problem. Let's read our example. Jason drives 50 miles to a train station and then continues his trip with a 210-mile train ride. The car travels 20 miles per hour slower than the train. If the total travel time is 4 hours, find the average speed of the car and the average speed of the train. So again, this is called a uniform motion problem. Uniform meaning the same. So we're assuming that we're finding the speed of the car as if the car traveled the same speed throughout its whole entire journey. And the train also traveled the same speed or the average speed over the whole entire journey. So there might have been some fluctuations in speed, but we're going to say on average, what was its uniform rate? Because it's a uniform motion problem. All right, so we need to look at all the information that we are given because we're given quite a lot of information. We know it's a uniform motion problem, so that leads us to the formula distance equals rate times time. And you'll notice what I'm doing here is I'm filling in these columns in our table. These tables are really helpful for uniform motion problems because they help you organize all your information so it doesn't seem so overwhelming. If you can break it up into smaller parts and visually see each piece of your equation, I think it makes it a lot easier to write and solve your equation. So we're going to have a column for distance, a column for rate, and a column for the time. Now, that's our general version of the formula, distance equals rate times time, but there's two other versions. If we wanted to solve that formula for time, we would divide both sides by r, and then time would equal distance divided by rate. Or if I needed that equation solved for the rate, I could divide both sides by time and rate would equal distance over time. So we might also use another variation of this formula as we dig a little bit deeper into the problem. Okay, I want to add some other labels to our table. We basically have two modes of travel, a car and a train. So the first row is going to be for all the information for the car, and the second row, I'm going to include all the information for the train. Now let's start highlighting all of our info. Jason drove 50 miles in his car, then he got in the train and drove another 210 miles. So I circled those in blue because those both represent a distance, just a pure distance, 50 miles and 210 miles. Then the sentence next tells us the car travels 20 miles per hour slower than the train. So I used a new color, like an orange color, to highlight the information about the car being 20 miles per hour slower because that's a rate, miles per hour. So that information is going to help us with the rate of the car and the train. And then I'm also told the total travel time is 4 hours. So I circled that in green because that has to do with time. That's just hours. So that has to do with time. So some of my values refer to the pure distance traveled. Then the 20 miles per hour slower, that's going to help me out with the rate of the train and the rate of the car. And then the total travel time is the time for hours. Okay. And then we need to find the average speed of the car and the average speed of the train. And keep in mind, when we say the word speed, that's miles per hour. That's a rate. That's a rate of change. So when we see R for rate, we're talking about the speed of the car and the speed of the train. Okay. I have some scaffolding questions down here where it says, number one, what are we being asked to find? So notice we're not diving right in yet and writing an equation. We still want to make sure we understand what we are being asked to find, and we want to set up the proper variables before we dive right in and write an equation, because the more information we have, the easier it is to set up our equation. So we're being asked to find in the unknown quantity or quantities. We need to find the speed of the car and also the speed of the plane. And that was the red underlining I did in the problem. It said find the average speed of the car and the average speed of the train. So I'm looking for two rates, one for the car, one for the train. All right. Now for number 2, oh, actually, no, let's go back here. I circled speed in orange just to remind us that speed is just another word for rate. So anything I put in that column for R is going to have to do with rate or speed. Okay, question 2, it says define a variable to represent the unknown quantity. So let's go back up and look at our problem. The car travels 20 miles per hour slower than the train. So if I knew the train's speed, I would just have to subtract 20 and then I could figure out the car's speed. So when I'm setting up a variable, I'm going to start with the speed of the train and I'm going to let that be plain old R for rate. So R is just the speed of the train. So in my table, I can fill in R for the column for rate with the row for train. So the speed of the train right now is just R. I don't know what it is, but I do know that in relation to the train, the car is 20 miles per hour slower. So the expression R minus 20 is going to represent the rate of the car. Okay, so I have the column for the rates filled in. Let's fill in some other boxes in our table. I can do the distances, right? I know that the car traveled 50 miles and the train traveled 210. So that was nice. I can fill that in. Now I just need to fill in the empty spaces for the time. I need something to fill in for the time that we spent driving in the car, and then I need to fill in the time we spent driving in the train. So we're going to use the version of the formula T equals distance over rate. So our time is a ratio of the distance we traveled divided by the speed at which we traveled, and that tells us our time. I know it mentions the total travel time being 4 hours, but that doesn't mean the car and the train were each 4 hours. It means together they traveled for a total of 4 hours. So however much time he spent in the car, if you add it to the time he spent in the train, that's the total of 4. So I need to figure out an expression to go in each one of these green boxes. And then I know that together, those two expressions will have a total of 4 hours. And then that's going to help me with number 3, where it says write an equation to describe my situation. But first I need some ratios for time. So I need the ratio of the distance divided by the rate. So for the car, the distance was 50 and divided by its rate of R minus 20. So that expression represents the car's time. And then for the train, the distance was 210 divided by R for the rate. So that expression represents the time of the train. And now I know that if I add those two expressions together, I get a total of 4 hours. So in number 3, we have to write an equation. So I'm going to make an outline first. The time spent in the car plus the time spent in the train should equal a total of 4. So now I'm going to put in my expressions. So the time spent in the car is represented by 50 over R minus 20. If I add that to the ratio of 210 over R, that's a total of 4. So I put a box around that. That's definitely not my final answer, but that is the equation that will get me to my final answer. So that is a rational equation. I hope you recognize that as a rational equation. And in order to do step 4, where I solve it, I need to first identify the LCD. So the LCD of my rational equation here is R times R minus 20. So it's the first denominator times the second denominator. And then I'm ready to do step 4, where I'm going to solve. I'm going to start another video to solve it. So at this point, this video is going to end. You can try to solve it on your own and then watch the next video and see if you get the right answer, or you can just continue along on the next video and continue filling out your notes.